Hey everybody, and welcome to your first video over factoring trinomials. So in our previous videos we discussed greatest common factor and difference of squares, but what happens when we can do neither one of those? For example, when we factor in this video, we're going to be looking at the form ax squared plus bx plus c, and this is standard form of a quadratic. Specifically in this video, we will be talking about where a is equal to 1. In a later video, we'll be talking about when a is not 1. So if you take a look here, here is the factored form of a quadratic, and here is the standard form of the same quadratic. What is happening here is that in the past, I have given you these two binomials and told you to multiply to get the standard form. Then, what we are doing now is I'm going to give you the standard form, and I'm going to ask back for it in the factored form, and that is what we call factoring. This is very important because when we graph quadratics, we'll be able to find the solutions in factored form. We'll be able to see where the quadratic crosses 0 in factored form. It's not done easily in the standard form, so that's why we have factoring. Alright, so when you factor with a is 1, what we are looking for two numbers that will multiply to c, but will add to b. So for example, we have two numbers, p and q, and we know that p plus q must equal b, and that p times q must equal c. So for example, I have x squared plus 6x plus 5. I'm looking for a number that adds to 6 but also multiplies to 5. Now this is where your factors will come into play. What I want you to do is off to the side, find the factors of 5. So the factors of plus 5 are 5 times 1 and negative 5 times negative 1. These are the only factors of 5. So taking a look here, if I were to add 5 and 1, I get 6. If I add negative 5 and negative 1, I get negative 6. So our answer here is going to be positive 5, positive 1, because 5 plus 1 equals 6, and 5 times 1 equals 5. So the answer is x positive 5 and x positive 1. So x plus 5 times x plus 1. Alright, so here's our next example. We have an example here where we're looking for two numbers that multiply to 24. So multiply, but add to 10. Now you'll notice that they've already done the box for you. The factors of 24, 24 and 1, 12 and 2, 6 and 4, 8 and 3. If I were to add 24 and 1, I get 25. That's not the 10 I'm looking for. 12 times 2 is 24, but when I add them, I get 14. That's not the 10 I'm looking for. 6 times 4 is 24, and it adds to 10, so this right here is the correct factors of 24 that we need to use. So our answer would simply be x plus 4 times x plus 6, or x plus 6 times x plus 4. It's the same thing by the commutative property. Now, one other thing I wanted to point out here is that you can check your work by multiplying the binomials together. When I multiply them, if I end up with the same standard form as I started with, then I know I did this correctly. So you should never, ever, ever miss a factoring problem because you can always check your work. Alright, so let's work through this guided solution. I need to find two factors of 16 whose sum is 10. Now I am looking for positive factors, and the reason I know that it's positive is because when I multiply I end up with a positive, so that either means positive times positive or negative times negative. But my middle term is positive as well, and the only way I can result in a positive number by adding is by having two positive factors. So when I have two positive factors of 16, they need to add to 10. So let's make a list of the factors of 16. 16 times 1, 8 times 2, and 4 times 4. So when I add 16 and 1, I get 17. That is not the 10 I'm looking for. When I add 8 and 2, I get 10. That is the 10 I'm looking for. So really, once I find my factors, I can stop. But if you want to complete the table, 4 plus 4 is 8, and that's not my answer. So the factors I need are x plus 8 and x plus 2, because they have a sum of 10. So x plus 8 times x plus 2. Now what I want you to do is I want you to pause and check, did we do this correctly? Multiply these two binomials. Alright, so when we multiplied, we noticed that the answer was the same as the original standard form of the quadratic that we were given. That means I did this correctly. You'll also notice that when we multiplied, we ended up with two like terms, 8 and 10, or 8 and 2, which added to 10. Do you see why we have to add to that b term now? Alright, let's do another problem here. This time I want to point out that b is negative and c is positive. So what I'm looking for here are two negative numbers. I need two numbers that are negative, because when they multiply they will result in a positive number. But when I add them, they will result in a negative number. So negative 9 times negative 1, when I add it becomes negative 10. So our factored form here is w minus 9 times w minus 1. So you have to be careful about that middle term. So let's take another case when b is negative. I have c is positive, so I know I either need to multiply by two positives or two negatives. But since b is negative, I know it has to be a negative times a negative. So the factors of 6, now we're looking for only negative factors. So negative 6 times negative 1 and negative 3 times negative 2. So let's add these. Negative 6 plus negative 1 is negative 7. That is not the negative 5 that I'm looking for. Alright, negative 3 plus a negative 2 is a negative 5. This right here is the negative 5, my b, that I'm looking for up here. So the answer is going to be x minus 3 and x minus 2. Now there's one last case in which factoring can appear a little differently. Notice in this case that c is negative. What's important to understand here is that they will have different signs. The only way to multiply and result in a negative number is a positive times a negative. If you look at 7, 7's prime, and the only thing we can multiply 7 by is 1. However, there are still two sets of factors, one where 7 is negative and one where 1 is negative. So negative 7 times 1 results in negative 7. When I add them, however, it results in a negative 6, but I'm looking for a positive 6 here. So 7 plus a negative 1 gives me the positive 6 I'm looking for. So my factors are positive 7 and negative 1. K plus 7, K minus 1. So let's do a guided example here. You'll notice that C is still negative, so I know that what I'm looking for, that P and Q have to have different signs. That's the only way to get a negative number by multiplication. So the factors of negative 10, and we're looking for something that will multiply to negative 10 but add to 3. So let's list the factors of negative 10. Negative 10 times a positive 1. 10 times negative 1, negative 5 times a positive 2, and 5 times a negative 2. So now we need to begin adding, because what we're looking for here is this plus 3. Negative 10 plus 1 is a negative 9. That's not what I'm looking for. Alright, we said 10 and negative 1, so when I add those, I get a positive 9. That is not the positive 3 I'm looking for. Negative 5 and a positive 2 results in a negative 3. I'm looking up here, I see a plus 3. So I am close, but I am not quite there. And then a 5 plus a negative 2 results in a positive 3. That is what I'm looking for. So my factors are 5 and negative 2. So x plus 5, or not x, excuse me, y plus 5 and y minus 2. And that is your final factored form. Remember, you can always verify by multiplying the binomials to make sure you did it correctly. Alright, here are two example problems. What I'd like for you to do is find the factors of C that add to B, and go ahead and write it in factored form. So exactly what we just did on the last several examples, I want you to try for numbers 1 and 2 to check your understanding at this point. All right, hopefully you have unpaused and you are waiting to see if you did these correctly. So let's take a look at 12. 12 is positive and so is 7. So I'm looking at the positive factors of 12. 1 times 12, 2 times 6, and 3 times 4 are the factors of 12. When I add 1 plus 12, I get 13. Not exactly the 7 I'm looking for. All right, when I add 2 plus 6, I get 8. Again, not the 7 I'm looking for. When I add 3 plus 4, I get 7. This is the answer I'm looking for. So that means that my factors are 3 and 4. So it's x plus 3 times x plus 4. Remember, anytime you're not sure, multiply those binomials and see, did you do it correctly? All right, let's do the factors of 8. The factors of 8 are 8 and 1. And 2 and 4. 8 is positive and so is 9, so I'm only going to be looking for positive factors. 8 plus 1 is 9. Oh, look at that. 9 is the middle term. I don't need to add anymore because I have found my factors. My factors here will be 8 and 1. So this will be x plus 8 times x plus 1. Now remember, you can write this also as x plus 1 times x plus 8. These are mathematically the same thing because of the commutative property of multiplication. Same thing here. You could write x plus 4 times x plus 3 and it would still be correct, as long as your factors are the right factors with the correct sign in front of them. Alright, so we have 4 more examples that I want you to try. Okay, I want to give you a hint. On these problems, you'll notice that b is negative. Okay, what that means is I'm looking for 2 numbers that will multiply to a positive but add to a negative. That's going to be your negative factors. Down here, you'll notice that c is negative. In order to multiply to get to a negative, the only thing I can do is have different signs on each of my factors. So take a minute and work these 4 problems. Pause the video now. Alright, so let's take a minute to talk about each one of these in order. So number 3, what I did was I found the factors of 27. I knew that they would both have to be negative in order to add to a negative 12. So when I added my factors, I noticed that negative 3 plus negative 9 gave me the negative 12 I'm looking for. And negative 3 times negative 9 results in the positive 27. So my answer is x minus 3, x minus 9. On number 4, I was looking at the factors of 20 that would add to negative 9. So I listed all the negative factors of 20. When I added each one of these, I got negative 21, negative 12, and negative 9. Negative 4 times negative 5 multiplies to a positive 20, but negative 4 plus a negative 5 adds to a negative 9. So those are my factors, x minus 4 and x minus 5. Okay, scrolling down number 5, I'm looking for the factors of negative 21. In order to multiply to get a negative, I need different signs. So there were 4 sets of factors here, negative 1 and positive 21, positive 1, negative 21, and so on. And you'll see that I have added all of these, and the only one that results in the positive 4 I'm looking for is negative 3 and positive 7. So it's y minus 3, y plus 7. Be careful here, the original variable is y, so our final answer should also include a y. Taking a look at number 6, we have a lot of factors of 24 first off, and then on top of that it's negative, so we end up doubling it because we have different signs. So the factor 1 and 24 you have to write twice. One as negative 124 and the other as 1 negative 24. So there's a very long list of factors, and when I add negative 4 and 6, I get the positive 2 I'm looking for. So z plus 6, oops, and that should be a z. I got on to you about that. And then z minus 4. Alright, so that is your final answer. Double check your variables, make sure your variable ends up the same in the final answer. That's it for factoring when a is 1. We'll talk about factoring when a is not 1 in the next video. See you then.